I'm just going to do one more example. It's similar to the last one, but it's just a little more involved. So if you'd like to watch a little more involved example, this would be for you. Let's solve 2q plus 1. Oh, let me just anticipate and write that on the next line. We're going to solve 2q plus 1 times q plus 1 equals 2 times 1 minus q plus 6. I won't write the recipe on the side because I'm going to need a little more room here. I'm going to multiply this out. Got to do some FOIL over here, distributive property, and then start moving things around. When we FOIL this, we'll have 2q squared plus 2q plus q plus 1. And using the distributive property over here, 2 minus 2q plus 6. We can simplify on the left. 2q squared plus 3q plus 1, and 2 plus 6 is 8, so we've got a minus 2q plus 8. Now, I'm going to move these to the other side, so I'll add 2q and I'll subtract 8. And I will have 2q squared plus 5q minus 7 equals 0. I'm not going to find a common monomial. I'm not going to factor by grouping, which brings me to the trinomial. My product is going to be negative 14. My sum is going to be 5. Positive 5. And that's got to happen with a 7 and a 2. 2 times 7, I want the negative on the 2. Negative 2 plus 7 is a positive 5. So I'm good. And we'll have 2q squared minus 2q plus 7q minus 7 equals 0. Factoring by grouping, we've got a 2q times a q minus 1 plus a 7 times a q minus 1 equals 0. Pulling out the q minus 1. Equals 0. Setting each factor equal to 0, q minus 1 equals 0, that's a q. So q is going to equal 1. Best just to write adding 1 to each side. You have to be especially careful on problems like this. It's where most people start dropping signs. Subtract 7, or putting things in the wrong place, numerator and denominator wise. Divide by 2. And we'll have q is equal to negative 7/2. So our solution set is negative 7/2 and 1. And I'll leave you to check that in the original. And that is the end of this segment.